Hello, my name is Joel Schneider, and I'm going to talk about simulating data according to a specific structural model. There are many reasons that you would want to simulate data. One of the reasons is that you have some new statistical procedure, and you want to check how often it gets the right answer. You can't do it with real data because with real data you don't usually know what the right answer is, but with simulated data you do know what the right answer is, and you can check how often your procedure works. Another reason that you might want to simulate data is that you want to see how often some configuration of scores occurs and the algebra is getting difficult, and sometimes it's impossible. And so simulating the data can give you a reasonable answer to your question without having to go through all the algebra. One reason that I like to simulate data is that I try to model what clinicians do with assessment data. For example, there are decision rules of when should you test and retest, and how many indicators do you need to measure something well. With simulated data, we can get approximate answers as to how well these decision rules work. Simulated data works pretty well for evaluating a procedure or an algorithm. It is, of course, hopeless in helping you discover new scientific truths about nature. In order to do that, usually you need to go out and measure stuff as they occur in nature. There are many ways that you can simulate data. Sometimes these solutions cost a fair amount of money, and if they're free, they're often fairly difficult to implement. And so what I've decided to do is make a free or nearly free solution that is reasonably simple. The software that I'm using is R, RStudio, and Excel. R and RStudio are free. Excel is not free, but most of us have it anyway. R is a statistical program that is wonderful, but is not exactly user-friendly. You can make R a little more user-friendly with various packages. One of the better ways of dealing with R is to use RStudio. So first I download and install R, but I rarely open R. Instead I control R via RStudio, so downloading RStudio and installing it should get you to where you need to go. I'm going to use Excel as my graphical user interface, and then it will generate code in R. I'll take the code, paste it into RStudio, and then run it, and it will generate my data. The R packages that my code makes use of are these three. If you don't know what an R package is, it's a bit of specialized software. You don't need to download this because the code will check to see if you have these packages, and if not, they will be installed automatically. So let's simulate some data. Suppose that we have this model. We have two latent variables. Each of them has 3 indicators. This is the correlation between the 2 latent variables, and these are the standardized loadings. These errors, or these residuals, have their own variances, but the R code will estimate them. We don't need to know them. The R code will assume that all of your variables are standardized, that is, all the latent variables and all of the observed variables are z-scores. After the z-scores have been generated, the Excel spreadsheet will generate code so that they will have a mean and standard deviation that you specify. So let's go to the Excel spreadsheet. In the spreadsheet, there will be no pictures, but I've pasted this picture so that we can see what we're doing. When you open the spreadsheet, you might be prompted to enable a macro. A macro is a bit of code that can run under the hood. Some macros have malicious code in them, and for that reason, Microsoft will prompt you to see if you want to enable the code. I promise that my code is not malicious, and you can open it and enable it safely. Some people have their security settings in Microsoft Office set so that they can't even enable macros. In the options, you can change your security settings so that macros can be enabled. All you would do is close this file down and open it again, and you should be prompted to enable the macro. In the tabs below, click Indicators, and you'll see this sheet. You specify the variable names. I've typed them in already, but as you type, the size of this box will change. On the Indicators tab, we show which of the variables are latent variables and which are indicators. So in this column, for the latent variable G, we show which of these variables are indicators of G. G1 is an indicator of G, and we can enter its standardized loading like so. So this standardized loading from G to G2 is 0.8, and then from G to G3 is 0.9. So I'll enter them now. Now we go to the H column, and we have 3 indicators, H1, H2, H3, and the loadings are 0.5, 0.6, and 0.7. So now we have all of our indicators, but we're still missing this correlation. So I click the Correlations tab, and you can see this. Now, all of the paths that have already been specified are blacked out. So if you enter something in there, they will be ignored. All we want to do is specify the correlation between G and H, and that is 0.3. Now, if we had more work to do in terms of regressions between latent variables, or even between observed and latent variables, we could specify this in the Regressions tab, but that is not needed here. If I want to specify the means and standard deviations of my variables, I can do so in the Means tab. If you leave it blank, it will assume that you want z-scores. The last tab to specify something is the code. There are some options. I can specify my sample size. I've specified a sample size of 10,000. If all you want is to generate code, then you can uncheck SEM code and create CSV file, and you'll get some R code that will generate random data in R. However, if you want a file that can be read by other stats programs, you can click CSV, create CSV file. And if you want R to analyze your code according to the model that you specified, then you can click SEM code. Now we can't see anything because nothing's happened. I have to actually run the macro, and I do so by clicking this button, Update Code. So here we have a lot of gobbledygook, but it's been selected, it's been copied, and all I need to do now is paste it in R. I'm going to use RStudio to do this task. So here I am in RStudio, and it will run my R code. I click File, New File, R script. So this is a script that I can run. I'm just going to paste, and you can see that my code has been pasted here. You don't need to understand the code, but you can feel free to change it as needed. All you have to do is select it all and then run it. So if I click Run or Control Enter, the whole code will be run. After running, it will generate a CSV file and open it according to the default program that opens CSV files. In my case, that would be an Excel file. So automatically it opened this file here. It has all of my variables. It also has all of my error terms and disturbance terms, and it has 10,000 rows because I specified a sample size of 10,000. So there it is. I can save this anywhere that I want, and I can open it in any statistical program. Essentially all statistical programs can read CSV files. In RStudio, you can see that SemPlot generated a path diagram. It's fairly simple, and sometimes it gets a little bit wrong, but if I want to export it to a PDF or something like that, or an image, I can do so. In addition, if I look here in the console, you can see that it estimated my model, and it gives me some fit statistics, and it also shows me the loadings and standardized loadings. What if I need a correlation between my error terms? So here we have a standardized correlation of 0.4. I can go to the Correlations tab, and it was between H1 and H2. I can put in my term H4 here like that. What if instead of a correlation between G and H, I want a path from G to H, like so? Now we have a disturbance term. Suppose this path is 0.3. Then I go to my spreadsheet, and I click on the Regressions tab, and I put in 0.3. Now if I go to the Correlations tab, I didn't erase the 0.3 that was there, but you can see it's blacked out, and the code will not specify a correlation anymore. But I could delete it if I want to. Regression paths don't need to be just between latent variables. We can do them between observed variables, for example from G3 to H1. We can even specify paths from latent to observed or observed to latent. The place where we would do that is still in the Regressions tab. So we wanted one from G3 to H1, so we go the G3 column, and we find the H1 row, and we put in our path. Now when I go to code, I click Update Code, and I go back to RStudio. I'm going to select it all, I'm going to delete it all, and then paste. And now my new R code will run this new model. If I select it all and run, I get my new CSV file. It has everything, including my disturbance term for the H variable. So that's my spreadsheet. It is very much a beta product, so if it has any errors in it, I'd appreciate hearing about it. If you have any questions about my spreadsheet, I'm happy to answer them as best I can. Thank you.